Today we are beginning Chapter 11, our last chapter of the year. Chapter 11 is where we start applying what you've learned about flat two-dimensional shapes to three-dimensional shapes. First off, the three-dimensional shapes you'll be working with the most are called polyhedrons. A polyhedron is a three-dimensional figure whose surfaces, or sides, are all polygons. Now, the official name for the sides of your three-dimensional shape is face. Those are called faces. Edges are the segments where two faces meet each other, and a vertex is a point where three or more edges meet. And those definitions will be especially important today. Now, good news is there's a shorter, less formal way to think of those three definitions. You could think of a face as just a side of your three-dimensional shape, an edge as the lines where two sides meet, and a vertex as the corners of your three-dimensional shape. So put your pencil down for a second, look at this picture, and decide which one is not a polyhedron based on the definition of polyhedron. You have 5 seconds. If you said C, well done. Because while a cylinder is a three-dimensional shape, not all of its surfaces are polygons. So C is not a polyhedron, but A, B, and D are. One thing you will be doing a lot today is counting how many faces, edges, and vertices a three-dimensional figure has. Remember, faces mean sides. So if you look at this picture to the right, it has one square base and then 4 triangle sides going around it laterally. So that's 5 sides total, 5 faces. Once you start getting to the edges, there tend to be a lot of those, so personally I recommend highlighting them as you count to make sure you don't miss counting one of them. So on the picture, highlight as you count the edges, the lines. There are 1, 2, 3, 4, 5, 6, 7, 8 edges. Vertices really just means corners in a three-dimensional shape. So if you count the corners, highlight them as you go to make sure you get them all. There are 5 vertices in this polyhedron. Euler's formula. Copy down this formula. F plus V equals E plus 2, where F stands for faces, V stands for vertices, and E stands for edges. Euler's formula is a way to calculate the number of faces, vertices, or edges when you don't have a picture and you only have 2 out of the 3 that you already know. So for question 2, to figure out how many faces the described shape has, I would take Euler's formula, I'd plug in 8 for edges where the E is, and I'd plug in 5 for vertices where the V is, and simplify it and solve for F to know how many faces the shape has. Pause the video here and try 3 and 4 on your own. Check your answers. For number 3, you should get that there are 12 edges. For number 4, you should get that there are 4 vertices. All right, for number 5, first count how many faces, edges, and vertices there are in the shape, just like you did with problem number 1. Pause the video until you're done. And go ahead and check your answers. There are 8 faces. There's 4 triangles around the top of the shape and 4 triangles around the bottom of the shape. I want to remind you that faces mean the outside sides, so the square that cuts through the middle of the shape does not count as a face. Edges. If you highlight them as you go, you get that there's 4 edges around the top of the shape, 4 around the middle of the shape, and 4 around the bottom of the shape, so that's 12 total. Vertices means corners. There's 1, 2, 3, 4, 5, 6 vertices. Now, one question you'll see quite a bit of on the homework is asking you to first count the faces, edges, and vertices, and then to verify that Euler's formula works for the given polyhedron. When they say verify Euler's formula works, it's really a way to check your answer, because if you plug in 8, 12, and 6 into Euler's formula and it creates a true result, you know that you probably counted right. And this is a good tip for checking your answer on things like quizzes on tests with Euler's formula. If it asks you to count for faces, edges, and vertices, but if you plug it in, it doesn't create a true problem. For example, you get 13 equals 14 instead of 14 equals 14. It means you counted one of the pieces wrong. Last thing we have to talk about today is the concept of a cross-section, and a cross-section is a really key thing to understand for the entire rest of Chapter 11. A cross-section is the shape that you get from the intersection of a solid three-dimensional shape and a plane. An unofficial way of thinking of a cross-section is you could think of it as the shape of a slice of a solid. So for example, if you take a three-dimensional loaf of bread and you slice it, you get this shape, and that is a cross-section. Now, cross-sections take some time to really get good at identifying, so we're going to practice a little bit without writing it on your paper. So looking at this cross-section here, this slice of your pyramid, where this plane intersects the solid pyramid, the plane creates a rectangle shape. Now the direction you slice your shape to create your cross-section matters. For example, with a cylinder, if you draw a cross-section horizontally, it creates a circle. It's a circle-shaped slice. But if you cut it vertically, it creates a rectangle. It's a rectangle-shaped slice. Cross-section is also a word you'll see quite often in more academic books and articles. So you'll see it some in college when they're talking about taking a three-dimensional shape and looking at the insides of it. So they talk about cross-sections of ships, for example, in a history textbook. All right, so this one's not on your paper, but I want you to pause the video and in your head decide what shape each cross-section would be. A, you should get a square or possibly a rectangle, because if you slice it here where this plane crosses through it, it makes a square top there. Here, if you slice this prism vertically, it also makes a triangle shape. Pause the video here and write down the name of each shape you get when you take the cross-section of 6, 7, and 7b. Go ahead and check your answers. We just talked about how if you try to take the cross-section of a cylinder horizontally and make a circle, this is a bit of a trick question because it's not perfectly horizontally. This cross-section is slanted. Because of it, in the direction of the slant, the circle gets stretched out. It has to go farther this way in the circle than this way in the circle. So you end up with an oval instead. Last question is a challenge question. Draw a cross-section formed by a plane intersecting the upper left edge and the lower right edge of the cube. What shape is a cross-section? So if you take the upper left edge and the lower right edge and you cut to connect those two, the shape of your cross-section is a rectangle. Great job today, everybody. Don't forget to turn in a picture of your notes on Schoology when you're done.